Hello, everyone. My name is Mickey, and hopefully, we're going to spend a good time together and we're going to learn something new. I'm going to be talking about DevOps and what is this about, where it came from, and what it actually is, and what flavors it has, where it has developed in the last few years. So, a little bit of the agenda. So, we're going to cover why am I in front of you speaking, background on how DevOps came along, DevOps explained, flavors, and questions and answers. You can post your questions in the chat or we can go through them at the end. So with further ado, who am I? Quickly, I'm going to go through that. And so my name is Mickey. I'm actually a computer science graduate from the University of Edinburgh, and I've been working in tech since 2012. I do conferences and meetups quite often. I used to organize a conference. I used to organize a meetup. That's what got me into it and broke that presenter's barrier. I'm also a certified Scrum Master, and I'm currently an engineering manager at Templify. I suppose the qualification which comes in to be talking to you about DevOps is that is for the last, 8 years or so, I've been working in different various tech roles as a developer in tech in test team, as a build engineer, as a DevOps engineer. So this is why I'm happy to be talking to you about DevOps. So actually, I'm going to take you on a journey through back in time when IT actually started first. And if we think about it, the first digital computer was in 1939. And then that is giving us quite the perspective of how far away it was actually. And we actually got the first paid and full-time programmer only in 1945. So that's around the Second World War time. And one of the first project models describing how to work in that has been used is called Waterfall. That is from 1956. And actually, the World Wide Web didn't come along until 1989. So, a fun fact: the first Star Trek was actually in 1967. But the reason why I'm telling this is I want to introduce the waterfall model to you. And I know this is a talk about DevOps, but it kind of makes sense to understand where waterfall comes from. So before IT was a thing, we had manufacturing. A lot of the old companies, which in the 19th century, a lot of a company actually started in the 19th century. So if we look at Nintendo, they're from 1887 or something like that. IBM is, and they also started as manufacturing of playing cards. We have IBM, who started with manufacturing of watches in the roughly around the same time. And those were actually the people, the companies which had money to actually invest later on in technology and in computing. So actually, they took some of their existing setup and actually applied it into IT. And one of those setups is Waterfall, where in Waterfall we have we start with requirements being gathered and after that process is done, we move into design. Design people work on it, and once they're complete and we have an exhaustive design, only after that development actually starts. And once we have a finished developed product, that goes to testing. And the test engineers would test it, maybe find bugs, verify it across the requirements, give it back to development or back to requirements, even up to that point. And in a lucky scenario, where we had, okay, testing is done, everything's good, we'll go to deployment and then maintenance. And as I mentioned, this is actually a model which has been around for even before the year it was created. But what it meant was that we had the following departments within the IT, and We had business analysts who were responsible for the criteria. We had design and development and engineering who are looking into the code, wrote it to match the design. We had the quality assurance department as well. A lot of companies also had integration, who those were folks who would take the code that we have and actually deploy it to production, set up your production environment, and then deploy to it. And then you would end up with an operations department where you would have product and system maintenance. So we had all of those different departments that were working around the same products or on multiple products at the same time. So that was that's what we kind of ended up having until what I would call the Renaissance age, until 1980s, when actually people started questioning things. Is that the right way to be working? I mean, waterfall has been around for 20, 30 years. So it was like, okay, is there a better way to do it? So in the 80s and up to year 2000s, people were experimenting. They were trying to find out what really works and what doesn't work. And one of the things which emerged in 2001 was actually Agile, for an example. And we also had before that even Lean in terms of manufacturing. So, and those practices and mindsets and methodologies, they were centered a lot around how teams iterate and with the short development cycles and faster feedback. So people wanted to deliver faster, because with the waterfall model, you would quite often end up working on the same product for up to 10 years, if not longer. There have been cases where you would start with the software for a bank, for an example, and the requirements would be set in stone, everything changes, but development takes longer. So by the time the finished product is ready, you actually have new bank regulations, for an example, so you start all over again. So it was common for projects in software to take quite a long time to be developed. So that was one of the reasons why in the 80s, 90s, 2000s, people were looking at shortening that life cycle, getting that feedback faster to make sure that they are delivering the right value. And also at the same at that time, there were various conferences happening to talk about Agile. And in one of those conferences in 2008, a gent called Patrick Dubois ended up wanted to have a conversation and with some fellow friends on what does it mean to be Agile in infrastructure. And this is actually the start of DevOps. Patrick Dubois is considered the godfather of DevOps, the person who ended up coming up with the term. But it actually started, the original idea, it was that he was at an Agile conference, and that's where it ended up happening, the magic. And what ended up emerging is that in general, we have the most popular setups, which is you have a development team who works on developing an item, a product, a feature. You have the quality assurance, and you have operations. So QA would be testing the code which development does, and operations is then going to handle with deploying the already ready product. So development would package, imagine it as a present. Development would pack a present. It would be all nice and shiny. QA would make sure that the right content of the present is. They wrap the pretty bow on top of it, and that is then shipped to operations, who had to unwrap it and make sure that that it's working and give it to customers for usage. And in the Renaissance age, there were a lot of questions of what happens if things got closer. And this is where Patrick Dubois' idea is coming across. How do we work closer together? How can we be agile with infrastructure, with operations as well, rather than just thinking about development or QA? So how do those three departments, which have been or entities of merge together, and what comes as a result of it. So as you can imagine, that is what DevOps is. It's the merge of it. So breaking those barriers, and here is where we go, is it's increasing the transparency, breaking the barriers between the departments, increasing that communication between the teams and the collaboration. And this is all to encourage us to share the responsibility and having more self-autonomous teams as well. So if you have a self-autonomous team who share with shared responsibility, then you have a better ownership of a product, and you're able to iterate, and you don't have that passing of the present back and forth. For an example, it wouldn't be a surprise for operations when they open the present and find out the surprise there. They would have already known what it is, and they have prepared or worked with you with development. So it's the DevOps culture is about keeping an open mindset towards communicating and accepting also the failures, because as Agile is trying to get us to get faster cycles and being able to incorporate the feedbacks, it's also in DevOps we're trying to also have there is nothing wrong with failure as long as we can recover fast to it. It's that acceptance of it, incorporating it in, and learning from it. It's those failures are part of our life cycle. And in general, when somebody describes DevOps, quite often you end up hearing that sentence of you build it, you run it. And the idea here is that exactly you have that shared ownership, shared responsibilities. So rather than pass it over the fence, as what was happening before in a waterfall model, you end up actually having a full ownership of the full cycle. Tell me if I'm speaking too fast, by the way. So this is a formal definition of DevOps. There isn't like an official definition, but this is what the one of the most popular ones out in the market on the web, and it's by Gartner. I'm not going to be reading through that. What I think we need to look into is actually what DevOps is, and it's actually practices. It's ideas and practices which are shaping us around breaking those barriers, maintaining that collaboration, and introducing the right tooling to make it easier for us to work together. So when we look at it, it's a collection of practices. These are not all of them. I think those are the most popular ones that you would hear being associated with DevOps. There are some which are debatable, so that's why I haven't included them. But I think that those are the key ones, and we're going to spend a little bit more time on them. So collaboration is exactly what we saw in what provoked Patrick to come up with the term Dev and Ops merging together. And it's basically us working together on this. And it's through automations where we actually get the right tools to maintain that collaboration that we're trying to. So 2 chains in terms of to do the development and the deployment. So having a continuous flow rather than piece by piece where you don't know how the puzzle fits. And to achieve that, so we're saying automation, but it's a scary word. You don't know where to start. So you're like, okay, how can we break it down? What is it more underneath it? And one of those first things is actually when we're going to talk about continuous integration. So if a development team consists of, normally an agile development team can consist of between 3 and 7 people roughly. Ideal number tends to be 5. People like that one. So if you have 5 developers, the idea about continuous integration is people share code on a continuous basis. They could commit to Git, and the other developers would instantly have access to the latest piece of work. They're able to review it, approve it, see if it makes sense, yes or no, and decide, okay, yeah, we're happy with that. No, I think we need to rework it. But it's about that constant visibility around what is it that we've done, and getting that fast feedback. Are we doing the right thing? And this is allowing us to okay, you've added a button to your website. If you think about it, you're introducing it. You're saying, okay, can somebody please accept this and tell me is that the right button? Is that matching what we want to do as vision? And then your fellow engineers like, yeah, great. So that ends up becoming part of your product. And at that point, you also start, and that is being done on a continuous basis. You commit on multiple times a day. It's in the 80s, you would think, for an example, and even up to now, there are companies and places where a code is being shared through zip files, where you're actually trying to find out what is it that changed. While with the continuous integration approach, you see exactly what change has been added. You have a timeline, and you're able to collaborate and contribute on those changes. So moving away from sending files over the internet to a more centralized approach. And it comes with some additional benefits here, because it allows us to introduce something like continuous testing. So rather than waiting for the design and for the development to be done, and only then test it, we're trying to move testing as early as possible. Even like test for spelling mistakes, actually include that before anything. So you can't even, there are rules, for an example, and options where you can say, okay, if this doesn't pass my spell checker, I can't even share it with the developers. And okay, if your developer has approved you adding a button, then maybe there are going to be some additional tests that can be performed after the integration to make sure that maybe you haven't introduced any security vulnerabilities, or you haven't added some secrets which you're not supposed to do. So actually testing moves from being almost the last one to be done to one of the first things to happen. And testing is also starts becoming more, there is more ownership of it from developments as well as QA, as well as operations. Because if you don't have tests, a lot of companies would say, well, if you don't have tests on this piece, we don't know if it's going to work or not. So you're not actually allowed to ship it to production. So you need to have certain standards in that regard, and they are being enforced. And when we're talking about shipping to production, what we mean here is like that piece on continuous delivery, which you see down in the left corner. So with continuous delivery, is like, okay, you've added your button, your fellow developers have agreed to it, and it is the right one. It passes the tests. You're able to open the button on all browsers. But then what happens next? So previously, it would have been given to, packaged with a nice pretty bow and given to operations to deploy it for you at a convenient for them time. And it might even happen without your knowledge. What happens here instead is using automation and tooling to actually, the same package which has been created by the developer and then tested. It's the same actual thing that is that you're able to, you yourself or automatically deploy to production under certain circumstances. You're able to release without that dependency on operations. Operations are now there to more help out with the tooling, with these processes around the automation, rather than owning the release itself. So you're able to control it yourself as a person. You say, I want that button to be available right now, or I want it to be available tomorrow. And you're also able to say, some companies also have implementation in place where okay, nobody's clicking this button, or we've not seen anything being generated. We want to revert it, or this button is causing errors, or it's being too much. Um, let's revert it back. So this is where you're, again, from Agile, you're getting that fast feedback. By having the fast delivery, you're getting the fast feedback. Is that the right thing? Is that doing the job that we're expecting it to do? But to be able to know that, you actually, that if it's if the button is being pressed or if it's generating issues, actually you need monitoring. And this is where you have the continuous monitoring piece. You're measuring performance, availability, you can track users' behavior. And this is how things keep on tying in together. So for an example, you'd introduce this button and things starts breaking. And you're like, if you don't have monitoring in place, you wouldn't know about it. And since you have shared responsibility in this, you have the visibility of it happening, and you go and act on it. You don't. There is no waiting for operations to tell you that something is broken with this package that you gave me. Can you please give me a new one, or what would you like to do? There is no waste in that time. And again, we're here relying a lot on recovering quickly in terms of is something through having continuous delivery, continuous monitoring. We're also able to recover from a failed state or from unsuccessful state fairly quickly. Or in the best case scenario, actually, you're fixing forward rather than rolling back to the previous version of your software working well. You're actually rolling forward with the next release that you do, with the next delivery of your package. You've actually fixed the issues that customers have reported or that you're seeing in your monitoring. So yeah, those are some of the most common practices. It's I suppose the easiest way to think about it is also by visualizing it here. So what ends up happening is you end up with planning a new feature, as in adding that button for, I don't know, maybe contact us. And you also have certain additional behavior around it, like maybe a pop-up happens that allows you to fill in your email address, send a message, and write a message and send it to someone. So you plan what this is about. You end up doing the coding for it. And if everything's okay, if then you'll end up with the build step where you would be checking for have I written good code? Is my code compiling? Is it building? Is it making sense? Then that is being tested, which we have on this stage. You can be testing. Is the button working? Am I able to add text? What is it that I can do? And after the test phase is complete, you can proceed towards a release. So think about it as a stamp of approval. You've gotten your stamp from test, and then you can move towards a release. And all of that, everything in this circle, by the way, can be done automatically. And this is where the automated tool chains are coming. This is what we mean. So you have a stamp of approval from test, everything's good, people are happy. So next stage is release, and you're like, okay, I want this button to be available maybe for only 10% of my customers, or only one customer for a beginning. That is all something that you can decide that, okay, I have a release, I'm happy with, I want to start small. So we can configure it, and maybe a release needs to be for specific time zone only, for a geographical location, so, or something like that. And then you proceed with the deployment, where we're exactly talking about. You're taking this release, it's all the same thing. You all have you've gotten the badge of honor for each one of those steps. And you move to deploy. You're deploying it to the location where you want it to. So my button is out now only for Europe, for an example. I don't want anybody else to see it for the European customers, or I want it to be deployed for everyone. That's also an option. And then we become with the operation part, where there could be like any changes to operations that need to be done to facilitate for that button working. Or it could be that you need to consider, well, not consider, but you need to have certain monitoring in place, or you need to check how this is behaving. So you basically at this point you are ensuring that your deployment is successful, that it's working as expected. You might have some tests even here as well to run on post production post deployment processes, and just to make sure, yeah, buttons there, everything's happy. They could be running consistently. And then you have the constant monitoring piece where you're like, okay, how many people are actually using it, or um, uh, do we have any errors that are being reported? And this cycle, this infinity, is actually happening many, many, many times a day. Um, I think it was Netflix who ended up saying that they deploy over what was it, 15 times a second or something like that. So they're starting, they are having releases every 15 seconds. Amazon are doing something similar. They can end up with million deploys a day. And it could be something small. And in most cases, it's something really small. But at the end, they're getting that fast feedback loop, realizing if this is working or not, and then fixing forward or fixing backward. It depends on what the company policy is. But this is repeating over and over again until we get the right product. We can get a complete product. And there are some arguments that there is never a complete product, but I think that's another topic. So I've already touched on some of that, but why do people want to do DevOps, and why do people like it? So from developers' perspective, it allows you to be more creative, innovative, and find out actually if something's going to work or not. You're reducing that time of waiting for operations to deploy or to give you some information, or in general, there is no time wasted. And you can run different scenarios. You can run different ideas. You can test your code in a different. You can decide how you want to test your code. Everything's automated at this perspective. At that point, you can still have manual tests as well, but it's not majority of your work at that point. So it gives you more confidence that what you're delivering is actually going to work, and you feel like happy that, yeah, my button is actually being used straight away. You get that gratification in place. And from operations side, they're happy too, because there is no more human errors in place. You'll have less manual tasks. So with the more automation pieces, it means that it's easier for them to debug, find out what the issues are, and they're excluding certain activities from that list. So less issues really. And they're able to save the time because they're not doing the routine tasks. If they have a task to refresh a button for some reason every day, that can get automated. And or every day you need to add a record somewhere for a reason. So like a timestamp or something. Previously, it might have been done by hand, but now that having automation in place, it allows you to spend less time on the routine tasks. And this is the next point is actually a bit of controversial one for operations, but in general, because you're doing smaller releases and you're having more thorough testing, you're able to pinpoint an issue faster. It actually lowers the risk of catastrophic failures. It doesn't remove the risk of failure, but the catastrophic failures are easier caught than before. You're able to react on items faster. And it allows you to also control when your releases are. Maybe there are companies who say, okay, we don't want to be releasing on Friday because we don't want to introduce any additional risk. And you're actually able to do that in an automated setup. So it allows you to schedule and think about how you would like to do things and prevent failures. And product owners, and here is probably more accurate, product managers like it as well, because they get faster feedback and reduce waste. It's previously, when we think about it in the example with the bank, 10 years to deploy software and just maybe at the end to find out that this is not what the customer wanted, and having to bin all of that and to start from scratch, that is huge waste of money, of people's time. It's extremely demotivating. So actually having this faster feedback loop allows us to gather that feedback, make sure that we're building the right product for the customers. We're also able to get insights on a constant basis if something is being used or not, if a design is successful or not. And from product perspective, that is key, because they want to make sure that they're getting the best value here. And I'm keep on talking about Agile, and I wanted to kind of cover this because some of you might have come across these terms and they don't, and there is a bit of an issue on, not issue, but it can be a bit confusing on what's the difference between them. What's the difference between Agile and DevOps and SRE, for an example? So when we when we talk about Agile and Lean, it's more about how the teams iterate in the short development loops. While DevOps has, so in Agile, it's focused on culture, and tools are not as important. It's agnostic in that regard. It doesn't matter. While in DevOps, the culture there is, it's more about collaborating, breaking down those barriers, and start using the culture to drive towards implementing the tooling that we need in place to maintain that culture. And in SRE, which is system reliability engineering or site reliability engineering, depends on who you talk to. It's if you have automation in place, it's about the automation being first and using the automation to drive towards the culture. It's a term which was introduced by Google. And there could be a talk just by itself. Actually, there are talks just about SREs and what is that exactly. But in general, what we're seeing there is the focus there is more on the tooling, and then that drives towards the culture, which is the complete opposite with DevOps. So this is from New Relic. It's not me who came up with that, but I really liked it, and it's a lot easier to relate to that. So I'm not going to be reinventing the wheel too much. And when we're talking about DevOps, we need to think about that DevOps has been around for a while. So Patrick Dubois ended up creating the term in 2008. From 2009, we already have DevOps specific conferences, and they have been going strong ever since. There have been more than 10 conferences in place. So it's not a new concept per se. It's been circulating for a while and long enough for people to actually buy into it and think about what else is there. How can we apply this in different perspectives? And one of the things which emerged fairly shortly after DevOps was DevSecOps, which is basically development, security, and operations. If we look back, we never saw anywhere in this presentation talk about the security guy. Normally, a company will have one security person expert, and they are at the end of the queue. It's not even like if you think the quality is at the end of the queue, no, the security gets involved quite often after the product has been deployed. And a lot of the issues they raise, we end up fixing retrospectively. So here it's the idea of DevSecOps is actually including security a lot sooner in the process, actually including it as maybe part of the testing stage, including some security tooling and practices to make sure that we don't forget about those and introduce vulnerabilities in our code. So there is that concept which has been super popular, and it allows us to trust more the code that we produce, that we're actually not exposing sensitive information, especially with latest regulations around GDPR, or the fact that there's been a lot of ransomware and attacks. This has gained more and more traction. I'm not going to talk about all of the ones that I've listed, but I would like to talk about the first three. So data ops is when we try and break the barrier between data and operations, because data is the new shiny thing. Everybody wants it, but it's quite expensive when you think about it. So unless you're working with your operations team, and well, as well as with your development team, it becomes really hard to manage and really complicated. So data ops spins around how can we use data and infrastructure and programming all in one to make sure that we get the data that we need in a good fashion. And there are already tools out there which can help. It's an interesting concept. Maybe you guys covered it in the data science talks that were present. And the third one, which I'm going to mention, is very, very controversial. And I'm saying controversial because it's we're never sure it's actually even if it's achievable, because we're talking about no ops, and that what this means is no operations, where everything is automated, where your operations team, rather than having to do anything with infrastructure or system support or all of these things, actually all of that is automated, and your operation teams turns more into an automation team. So creating the automation around and the support around the developers to make sure that we are able to maintain that no operations setup. But a lot of people think that that's nirvana and it's never achievable. But you never know. The technology, new technology keeps on emerging. Things get more and more sophisticated. So we are seeing that some of the traditionally operations pieces of work now has shifted more towards development or have been automated completely. So who knows? Maybe in 5 years, it's there's going to be no DevOps and it's just going to be no ops at all, and we're going to be in a no ops world. And if we're talking about BizOps and ArtOps, so BizOps is business and operations, where actually those requirements that we talked earlier about, it's like all of the barriers are down. And so we're actually having a team which consists of business persons, operations person, engineer, designer, everything in one team. So they're able to work autonomously and deliver value on a quick basis. ArtOps, that is an interesting one. I'm not too familiar with it. It's when we have architecture and operations blurring the lines and actually no lines. But I don't want to talk too much about it because I'm not an expert in it. So I don't feel that comfortable. But if we're looking at the summary, DevOps is a mindset and a culture to encourage collaboration, autonomous teams, and shared responsibility. And to achieve that, it pushes us towards implementing the right tooling in place to support that culture. So that's pretty much me. I want to present some resources for you and talk a little bit about them. So you guys know what's available out there if you want to touch up more. DevOps Days conferences, I strongly encourage them. I'm also biased since I ran one of them, but I think it's most engaging and open way of getting into DevOps. It's actually the conference which Patrick Dubois started in 2009. He's been attending most of the conferences. Now I think they have each city in each country in the world. You probably have had a DevOps Days conference. So there was one in Aarhus. There is in Edinburgh, London, Berlin. They're happening annually, and it's local speakers as well as guest speakers. And the idea is that we're fostering that DevOps community. We end up talking, and it's conference as well as loads of sharing of experiences. It's informal and quite and very frequently either free or with a very low entry of like a ticket entry just to cover venue and speakers. There was the 10th anniversary of DevOps Days. You have the link here. It's there are bunch of all of the conferences are recorded, so you can watch the recordings. You can check who the speakers are and get an idea of them. But I do strongly recommend it. It's from DevOps folks, developers, operations for other developers and operations. It's not a corporate type of conference. We also have loads of meetup events in general. So if you go on meetup.com, there would be maybe there would be a DevOps meetup in your area, but a lot of them can also be online, so you can join in and find out more information. And if we look more about reporting style of things, we have the DORA reports, DevOps report analysis or something like that. It's research analytics, something like that. So that they produce the state of the DevOps reports, and this has been running for the past 10 years as well. So pretty much in sync with the DevOps Days, and they've been conducting research and sharing on how large organizations are going through the DevOps process, the DevOps adoption. I thought personally that the new Relics way of explaining what DevOps is and getting into a little bit more detail was quite useful. So that's why I'm linking it. And some recommendations of people to follow in the DevOps world, of course, Patrick Dubois, but you have also Jin Kim, who wrote the Phoenix project, the Unicorn project. So there's been some interesting books he's released in collaboration with other folks. So do recommend him. He's quite an interesting chap. We have John Willis and Matty Stratton. They are both involved in DevOps Days and in the DevOps community for a very long time. Matty actually runs a podcast, so worth checking it out. And IT Revolution is actually a company which Jin Kim founded, I think. They've been involved. So they publish loads of books, they create webinars and events, so worth checking it out. For news, DevOps.com, worth checking it out. And conferences, the good thing is about conferences is if you want, you can attend them. They cost money, but they're also being recorded, so you can watch them later on YouTube. So some of the good ones, which I personally enjoyed, is DevOps Days, biased a little bit. QCon, the DevOps conference, DevOpsCon, go to. You can find the details on them online. But there've been many conferences. I think if you start from 20 to 21 backwards, or if you want to start from 2010, up to you. Both of those approaches are okay. You're going to be learning something new anyway. And with that, I'm ready for questions.
Thank you, Miki. Wow, this was such an interesting look at DevOps throughout history and how it emerged. There was a question in the chat, can you maybe explain the difference between DevOps and Agile? You already did, but yeah.
I ended up muting myself. Sorry. So if we look at this one, again, DevOps and Agile and Lean is one of the most common flavors of Agile that we talk about is Scrum. It's not the only one, but it's the most popular one. And the focus there is about the iterations and adding transparency, adding frequent feedback, and adapting based on that feedback. And yeah, so pretty much trying to constantly deliver value for the customer. The thing is, DevOps spinned off from Agile. So it was when we started thinking about Agile infrastructure that we started thinking about DevOps. And DevOps incorporates a lot of the principles of Agile in terms of the iterations, but it also focuses a lot about the collaboration and breaking the barriers, more having the cross-functional teams, and introducing the drive towards tooling. That's the one difference that I could think of right now that is major here, is that from Agile's perspective, the tooling doesn't matter. In DevOps, it's like those practices to maintain the culture, to set it up in place is the drive.
Would you say then you could use Agile and DevOps together?
Yes, absolutely.
In the sense that I guess Agile would be more of the process of developing in iteration, and DevOps is automating and tooling.
The DevOps is the focus on your tooling. So you can be agile and not do DevOps, but it means that you can still achieve fast feedback. You can still achieve releasing to your customers on a consistent basis. But if you incorporate the DevOps practices that we mentioned, and if you put the effort into the tooling, you're going to speed up your process. And that's the idea around it.
There's another question. What is the role of operations in a DevOps-driven organization?
That's a good one.
What is their role if everything is automated or focusing on tooling?
At the moment, we're not. I don't know of any company who is in the situation where they don't need operations. As in, nobody has been able to automate everything. But in general, the operations role is more about infrastructure, about reliability, stability of your product. So while developers tend to focus more about the application that is being deployed. So if you think about your website, operations is what is it deployed to? So if your application is a person and that person wants to move house, how do you construct that house? What is it made of? Does your human need a studio apartment, or are they looking for a house with a garden, or they need a house with a garden? So operations role is working with development to determine, okay, based on the candidate of the human, the application, what is it that we need to have in place to make sure that everything's working as expected, that the human's happy that your application is working. So even if we're able to automate everything, it's still it would mean that developers would need to get that more awareness of how is their application being hosted, how is it being managed, scaled. This is where the expertise of ops comes in.
Yes.
Did that answer the question?
Yes. Yes. One thing actually that I will ask you to talk a bit about is perhaps the second part of this two-part webinar and the content there, and kind of what the how the webinar is structured. That's okay.
Sure. So we're going then the part 2 of this is actually how do you get into DevOps? So it would be more about, I suppose, my personal journey through it. I did not start as an operations engineer, that's for sure. I when I graduated from university, I had no clue what I wanted to do. I knew what I find interesting, but I didn't know what is it that I want to do. So my university was more of a academic one. So from practice perspective, I was missing, do I want to be a developer? Do I want to be a tester? Do I want to be more of a designer? What do I want to do? So it's the next talk is going to be a lot more about what makes a DevOps engineer. What is the skill set that you would be needing or looking for to get into that field? What do you need to learn?
I guess that also ties in a bit with another question we have in the chat, and that is it mandatory to know programming for DevOps?
No, I wouldn't say that. So for an example, you need to have understanding of coding, like in terms of understanding what you're doing, but you'd end up finding out that a lot of, for an example, the sysadmins, they can't write code, or people who are coming in from a build or QA background, they can read code, but not necessarily write it. And with more of the automation tooling, it's more about getting the right processes in place, the right logic, rather than actually writing the code itself. Writing the code with and in recent times, it's more like writing, I don't know, drag and drop style. And this is where things are heading to these days with already configured modules, which so the building blocks are there. What you make out of it, like thinking about Lego, a lot of the coding has already been done. It's how you put it together to build the house that you need. So it still requires understanding of concepts, but not necessarily of being able to program it.
Mm. You mentioned in your talk the way that like you run it, you build it. I was just wondering, I mean, what are the roles within like DevOps? As not everybody needs to program, kind of what people do you have?
So what could be called a DevOps person or a DevOps engineer? It could be somebody who is looking at if we go here, a DevOps engineer can be anywhere on the reverse state. It could be maybe that the build stage. How do you configure a build? So you can be a build engineer. That is considered a DevOps engineer. It's one of the flavors. So your job is going to be more about making sure that the build matches the standards that we have, or it could be that the build has passed all the quality controls and assurances. So you have that possibility. It could be adding tooling. So you have this whole process, and you realize, well, if we want to incorporate security now, new security practices, it's about realizing where those practices would fit in, and introduce that tooling in place inside of your continuous integration, or would it be on a delivery, continuous testing, where and what you're doing. It could be that it could be that you're into operations and you're more like hands-on, and you want to be playing with the configurations required for an application and seeing that scales. So, for an example, originally the code has been written for maybe your human wants to live in a studio, but well, they got a girlfriend and a child, so they need actually something bigger. How do you scale? What is it that you need to do to accommodate for the changes coming in?